trying to solve simple trigonometric equations. And it says, solve each equation on the interval where theta is between 0 and 2 pi. But notice that the theta, it's 0 is less than or equal to theta. So 0 is part of the answer, but then it says theta is less than 2 pi. 2 pi is not going to be an answer on these problems on the front of our notes. And then I won't spend the time on it, but it says, then verify each equation is true by plugging it back in the values, the angles you found for theta. Well, the key idea on this problem, in terms of solving equations, is that the variable is the entire trig function. So in this first problem, the trig function that we're solving for is tangent of theta. We want to isolate that value. So what we're going to do is we're going to subtract the square root of 3 from both sides. And we have tangent of theta equals negative the square root of 3. Well, now what we need to know is which angle of tangent has a value of the square root of 3. And without lingering on that answer is, or tangent of pi over 3 gives us the square root of 3. But what we really need to know is, where is tangent negative on the unit circle? So that's going to go back to our all students take calculus. So what we need to know is what quadrants are tangent negative in. And in the first quadrant, all of the functions are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. Which means the second quadrant, where sine is positive, that means tangent's going to be negative in there. And what's the pi over 3 value in that quadrant? 2 pi over 3. Maybe I didn't ask the question very well. Well, we have another quadrant where tangent will also be negative. In the fourth quadrant over here, cosine is positive, which means that tangent will be negative. What's the pi over 3 angle in that fourth quadrant? Pi over 3. Two cosine theta plus 6 equals 7. Eventually what we want to figure out are the angles of cosine that equal something. But we have to get cosine by itself before we can determine that. And we're going to start by subtracting 6 from both sides. We get 2 cosine theta equals 1. Well, it's 2 times cosine of theta. So our inverse operation is going to be to divide both sides by 2. And now we end up with cosine of theta equals 1/2. And this is where our hand gesture can come into play. You can't see it on the video, but remember, with your left hand, where are we going to have one finger above that? And that's going to be our index finger, which means that theta is going to be a pi over 3 value. Then what we need to look at is, where is cosine positive? Once again, that's going to go back to all students take calculus. All of our functions are positive in the first quadrant, and we have an angle in the first quadrant. We have pi over 3. We're working with cosine functions, so we also need to have a pi over 3 in the fourth quadrant. And what is that value of pi over 3 in the fourth quadrant? It's 5 pi over 3. Be helpful. Number 3. 4 sine squared of theta equals 1. We need to get sine of theta by itself. And right now it's 4 times sine squared. So we're going to divide both sides by 4. When we divide both sides by 4, we end up with sine squared theta equals 1/4. So we're moving along the right track here. But we don't want sine squared, we want to know what sine is. So we have to do the inverse operation of squaring. Square rooting. So we're going to take the square root. So sine squared, square root of sine squared is sine. When we're taking the square root, it's going to be plus or minus. And one other little piece of information that might be useful for a couple of you is that when we take the square root of a fraction, we're going to take the square root of the top number, and we're going to take the square root of the bottom number. So then the question becomes, can we take the square root of 1? And we can. Can we take the square root of 4? Yes. So this becomes sine of theta equals plus or minus 1/2. Square root of 1 is 1. Square root of 4 is 2. And now let's use our left hand. Again, you can't see it on the video. But if we want to find 1/2, we're going to fold in our ring finger, because sine is going to be below that. And the angle that's represented with respect to our ring finger then is going to be pi over 6. Well, this one is less complicated maybe, because we need all of the values where sine is positive 1/2 or negative 1/2. So we need an angle in the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. What's the pi over 6 value in the second quadrant? It's 5 pi over 6. What's the pi over 6 angle in the third quadrant? It's 7 pi over 6. What's the pi over 6 in that fourth quadrant? And it's 11 pi over 6. Thinking of your unit circle backwards. We're given the value, now we have to find the angle. Problem number 4. 3 cosecant of theta plus 10 equals 4. Isolate the trig function. We'll start with that by subtracting 10 from both sides. And we end up with 3 cosecant of theta equals negative 6. So we just want cosecant. So it's 3 times the cosecant. We'll divide both sides by 3. We get cosecant of theta equals negative 2. And some of you might be like me. I pretty much know nothing about cosecant in terms of the values. The one thing that I know about cosecant is that it's the reciprocal of the sine function. So if we're dealing with reciprocal, we need to take the reciprocal of negative 2, which is negative 1/2. Hopefully for a few of you, based on our last example, we had sine of theta equals plus or minus 1/2 in the last one. Now we just have sine of theta equals negative 1/2. But ultimately, what we know is that our angles are going to be pi over 6 angles. But we need to know, where is sine negative on the unit circle? And I got to fill this in. All students take calculus. What quadrants are sine negative in? Well, tangent is positive in third. and cosine is positive in the fourth. So we need a third quadrant angle. That's a pi over 6. So what's the pi over 6 angle in the third quadrant? It's 7 pi over 6. The numerator is 1 bigger than the denominator. What's the pi over 6 angle in the fourth quadrant? It's 11 pi over 6. Number 5. 3 times the square root of 2 sine theta minus 2 equals 1. Isolate the trig function. So in this case here, we're going to add 2 to both sides. And we get 3 times the square root of 2 sine of theta equals 3. But we want sine of theta by itself. So 3 radical 2, that's in front of the sine, which is really that it's multiplied by. We're going to do the inverse operation and divide by 3 radical 2. And when we do that, the 3 radical 2's over here cancel out. And we're left with sine of theta equals, well, not only do the 3 radical 2's cancel out over there on the left side, but these 3's cancel out. But 3 divided by 3 is 1 over the square root of 2. Well, we don't know what value that is, but if we rationalize the denominator, we can figure it out. And what we're going to do is we're going to multiply it by a fancy form of 1. In other words, we're going to multiply by the square root of 2 over the square root of 2. When we multiply by those values here, we end up with the square root of 2 over the square root of 4. And maybe some of you wrote that, maybe some of you didn't. But what's the square root of 4? It's 2. So this is square root of 2 over 2. So now we have sine of theta equals the square root of 2 over 2. So we know the ratio. We need to go back and figure out the angle. We can use our hand gesture. When we fold in our middle finger is represented by pi over 4. And then what we want to figure out, this is positive the square root of 2 over 2. Where else is sine positive on the unit circle? Well, all, first quadrant, all, and that's our pi over 4. But we also are positive in the second quadrant. And what's our pi over 4 angle in the second quadrant? It's 3 pi over 4. Again, we need to know the unit circle to be able to answer these questions. As we take a look at the last problem here on our front page, problem number 6. 2 cosine theta minus the square root of 3 equals 0. We're going to add the square root of 3 to both sides. So we have 2 cosine theta equals the square root of 3. It's 2 times the cosine of theta. So to undo that, we're going to divide both sides by 2. And we get cosine of theta equals the square root of 3 over 2. So again, hand gesture. You can't see it on the video. But we need to have 3 fingers above for cosine, which means that we're folding in our ring finger. So the angle we're going to be working with is pi over 6. And it's positive. When we take a look at this, what we've got all students take calculus. We're dealing with cosine. We have the first quadrant, but where else will cosine be positive down here in the fourth quadrant. And what's the pi over 6 angle in the fourth quadrant? It's 11 pi over 6. Now, what we've been doing with the front page is we've been limiting ourselves to one time around the circle. And as you turn your notes over, we want to be able to do these problems so that we're not limited to just one time around the circle. And that's called the general formula. So you may highlight that, box it in, something. And this is what happens when we're dealing with the general formula. It says that if the two angles that satisfy the equation create the same line on the unit circle, keep the smaller angle and add a plus pi k after the angle. It doesn't make much sense to you yet. And the second bullet says if the two angles that satisfy the equation do not create the same line, keep both angles and add a plus 2 pi k after each angle. I don't want to overlook those steps. I know that they don't make sense yet. But as we look at this example number 7 here, tangent of theta equals the square root of 3 over 3. Well, what angles, keeping in mind, all students take calculus, what angles have a value of the square root of 3 over 3 for tangent? Well, 3 plus 3 is 6, so it's going to be pi over 6. But we need to be in the first quadrant, and we need to be in the third quadrant. What's the pi over 6 angle in the third quadrant? 7 pi over 6. Now if we mark this up on our circle here, here's pi over 6. Here's 7 pi over 6. Can we draw a straight line from one point to the other? Since I just did, we must be able to. So if you look back at the top of your paper, I'll flip back here. The very first bullet says, if the two angles that satisfy the equation create the same line, only, then keep the smaller angle and add plus pi k. So it's pi over 6 plus pi k. And what that k does is that represents a rotation around the circle. So it says that if we add pi k, we get over to here. And then we add pi k, we get back here, but we've got a coterminal angle. Add pi k, get here. Add pi k, get back here. And here. We can keep going around the unit circle as many times as we like, so that we're dealing with all of the values, and that's what's called the general formula.